So what I want to show everyone is how to find the vertex of a quadratic by two ways. We've already talked about how to find the vertex by completing the square. And that technique will always work. But there is another technique that is a little bit more direct. And there is a formula for finding both the axis of symmetry and for finding the x-coordinate of the vertex. And that formula is the x value will be the opposite of b over 2a. To show you that this actually works, I'm going to find something else about the quadratic first, which is where it's zeros. And to find the zeros, the quadratic formula tells us that x is going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So if we do all this, we'll get the zeros. And my claim is this is going to give us the axis of symmetry. Alright, so if I simplify this quadratic, it turns out to be negative 6 plus or minus the square root of 96 over 10, which if we split up and simplify is negative 3/5 plus root 96 over 10 and negative 3/5 minus root 96 over 10. Now I'm not going to reduce this anymore. Root 96 does reduce, but I like the fact that it's root 96 because I know that's close to square root of 100, which is pretty close to 10. So that tells me I'm taking negative 3/5 and either adding about 1 or subtracting about 1. Now graphically what this means is if this is my axis, then I know if this is about negative 1, that this number negative 3/5 is about right here. And then if I add about 1 to it, that's going to take me to about positive 2/5. And if I subtract about 1, that takes me to about negative 8/5. So these two dots on the outsides are my zeros, and this point in the middle, negative 3/5, is in the middle. And so because this quadratic is going to be symmetric, this is where the axis of symmetry is going to be. And so somewhere down here has to be the vertex, because a is positive, so it's going to have to open upward and go through the zeros. Let's see if I can hit that. Yeah, sort of like that. All right, so this negative 3/5 that I found through the quadratic formula, it comes from negative 6 and the 2/5 on the, or 2 times 5 on the bottom, which is really the opposite of b over 2a in the quadratic formula. So if I plug in the values from the formula right away, it's the opposite of 6 over 2 times 5, or just negative 3/5. And so by doing the opposite of b over 2a, we will have found the axis of symmetry. It's the same value. Now that's not enough. If we want the full vertex, we also need to find out what the y-coordinate is. So if we think of this like a function, so f of x equals instead of y, if we evaluate f at negative 3/5, that's going to give you the y value when x is negative 3/5, or what the y-coordinate of the vertex is. So if I plug in, it looks a little intimidating at first, but it's not too bad really. There's a lot of things will cancel. 6 times negative 3/5 minus 3. So reducing here, negative 3/5 is 9, squared is 9/25, times 5 is 9/5. This is negative 18/5. And then minus 3 is really minus 15/5. And if we combine those together, 9 minus 18 is negative 9, minus 15 is negative 24/5. So at this point we have the x-coordinate of the vertex, and we also have the y-coordinate. And so that's enough information to say that the vertex is at negative 3/5, negative 24/5. Now there is another way to do this problem, and that is we could do it by completing the square like we'd already done before. So that technique looks like this. Y equals 5 times x squared plus 6/5 x, parentheses, minus 3. The reason why the inside of the parentheses looks so radically different than the original equation is that we have to remember to factor out the leading coefficient of x squared from both of the first two terms, because we're going to make this into a perfect square trinomial. And then we leave the constant term kind of outside. Now we need to find out what number we'll add in here to make it a perfect square trinomial. We know it's going to be half of the b term, or 3/5. That value squared, or 9/25. Now in reality, we've added 5 times 9/25 to this side, or 9/5. So to keep the equation balanced, we're going to have to subtract 9/5. Now to finish up the process, we've got y equals 5 times. This perfect square trinomial factors into x plus 3/5 squared. And then this is negative 15/5 minus 9/5, which is minus 24/5. And so you can see from vertex form that the vertex is going to be at negative 3/5, negative 24/5. So either way, you get the exact same answer for the vertex. But you may find in certain situations that you would rather do the formula opposite b over 2a to find the axis of symmetry and then use that to find the y coordinate, or you can complete the square. The choice is really up to you.